Completing the square. So it is very nice when the equation for a parabola is in vertex form, like it is right here, because we can say that the vertex is h comma k. But not all equations come in vertex form, so what we're going to have to do is make them into vertex form. So the way we do that is by completing the square. The key to completing the square is this part right here, this x plus or minus something squared. So we're going to create an x plus or minus something squared in the following trinomials. Now, these are all called trinomial squares. It's a trinomial square because if you square it, it creates a trinomial. So I want to go backwards to see like how this looks. So if my trinomial square was x plus 4 squared, that came from x plus 4 times x plus 4. If you distribute, you can either distribute or do the box, you would get x squared plus 4x plus 4x plus 16, which is, if you combine like terms, x squared plus 8x plus 16. If we look at our other one, x minus 9 squared, that's x minus 9 times x minus 9. So that is x squared minus 9x minus another 9x plus 81, which gets us to x squared minus 18x plus 81. So let's see if there's a pattern here. My original number on this first one was a 4. But my two new numbers, when I distributed and collected like terms, is an 8 and a 16. Well, 8 divided by 2 is 4, and 4 squared is 16. So let's see if we can kind of come up with a very similar pattern on the other one. When we first started, we had a 9. We did have a minus 9. And we got an 18, negative 18, and an 81. So let's see if we can do the same thing. If I took negative 18 and divided it by 2, I get negative 9. Very nice. And if I take negative 9 and square it, I get 81. So those numbers that you end up with when you distribute are completely related to the original factored numbers. So we're going to use that idea to complete the square. In other words, we're missing the constant. We don't have a plus c right here. So here's the steps for completing the square. And you're only going to be given x squared plus bx. What you're trying to find is c. So what you do is you divide b, which is our coefficient of x, by 2, and then you square those results. We kind of saw that back up here. We took b and we divided it by 2, and we took that result and we squared it, and that's the constant here. We took b, we divided it by 2, we squared it, and we got the constant right there. So it is a pattern and we get to use that. So the factored answer, when you get your final factored answer, ends up being x plus or minus, depending on if it's a plus or minus problem, whatever b over 2 was. Because remember up here, when we divided it by 2, this number came from the original problem. So let's see how we can use this. So it says first, divide b by 2. b is always the number in front of x. So on this problem down here, b is 16. So I'm going to go 16 divided by 2, and I'm going to get an 8. Then step 2 says to square that. So 8 squared is 64. So that means that my constant, which belongs right there, is a 64. So I could rewrite this as x squared plus 16x plus 64. Now to get our factored answer, it's going to be a trinomial square. It's got to be, because that's how I created it. And it's an x plus, now let's look what we have here, b divided by 2. Well, when I divided b by 2, I got 8. So I'm going to say x plus 8 squared. Now let's just double check that really quickly. If I were to multiply x plus 8 by x plus 8, I would get x squared, 8x, 8x, and 64. And if I were to add 8x with 8x, I would get 16x. There's my x squared, there's my 64. Yes, I did indeed factor that correctly. So let's try another one. X squared minus 10x plus or minus, I have no idea what. So step 1, take b, which is negative 10, and divide it by 2. That's a negative 5. Step 2, take that result, negative 5, and square it. That's a 25. So that means that my missing constant to create a trinomial square is a plus 25. So if I wanted to write a trinomial square that starts off with x squared minus 10x, I would need plus 25. Now keep in mind, this right here is the key to our factored answer, that b divided by 2, because that makes it x minus 5 squared. So factored is x minus 5 squared. If you remember, factoring a trinomial where x squared is by itself, you might have remembered back in the day in Algebra 1, you're doing a diamond problem and you're trying to find what two numbers multiply to 25 and add to negative 10. That happens to be negative 5 and negative 5, which also gets you that answer right there. Okay, let's try one more. Now I am giving you one that has a fraction for a very specific reason. If you were to divide something by 2, it's the same as multiplying by a half. These are exactly the same thing. So if I take b, which is 6/7, and divide it by 2, I can then instead say multiply by a half. If I cross reduce, I get 3/7. Keep in mind, that's going to be part of our answer most likely. So I am then going to take that result of 3/7 and I'm going to square it. This is not as complicated as it looks. Basically, 3 squared is 9 and 7 squared is 49. So there is the constant that I'm missing to make a trinomial square. So I would have x squared plus 6/7 x plus 9/49. And if I were to factor that, I'm going to have x, remember this is our key for factoring, plus 3/7 squared. So there is our trinomial square, and that is what it is when it is factored.